All right, let's keep going. So we got more of these same type of percent amount product problems. So let's take a look at this one. Mike has a box of coins that he uses when playing poker with his friends. The box currently contains 44 coins consisting of pennies, dimes, and quarters. The number of pennies is equal to the number of dimes, and the total value is $4.37. How many of each denomination of coin does he have in the box? Now, 44 coins is not a lot of coins, so Mike could just count them out pretty easily. But if he wanted to be a little bit more challenging, he could do it this way. So, first thing we got to do is look at our percentages. So now, because we're talking about money, we have to just think, dollars and cents. So what do we got for coins? We got pennies, we got dimes, and we got quarters. So a penny, percentage-wise, we can write as a decimal as 0.01. So there's our pennies. Dimes, though, 0.10. Now, I have that line in there still, but we're going to just pretend it's not there. So we got our quarters, which are 0.25. So I'm actually going to add another line underneath it. So, okay, so we got all three that are being mixed. We're adding up all these coins, so that's why I added an extra line. So, okay, so we have all three denominations, but now we need our amounts. We want to know how many of each that we got. So the one thing they tell us is that the number of pennies is equal to the number of dimes. So if I were to say that X was the number of pennies, what else could I say? I should be able to say that X is the number of dimes as well, because it's the same. So if I have 5 pennies, I got 5 dimes. So because I got the same X, so that's good. But now comes the tricky one. So what about the quarters? I can't say X for quarters. I got to say something different. But look at what we got. We got a total of 44 coins. I've already allocated X dimes and X pennies from that. So I have to take those out of that total. So let's use our example. If I had 5 here and 5 there, how many would be left to get up to 44? Well, if I take 10 away from 44, that gives me 34. So I'd have to have 34 quarters to make this right. So no matter what I choose for my X's, I have to take them away from the total. Same as before. I want to take 44 and subtract 2 X's. That will give me my amount for my quarters. So you can always do that. You can always just try some examples and see what reaction has to happen in order for that third thing to come out right. So, okay, so we have that. Now let's get our products. So we got 0.01x, 0.10x, 0.25 times 44 minus 2x. So there's all of our quantities, but now what do we set it equal to? The only thing left is this $4.37. So that is what we want it equal to. So all three of those things have to add up to 437. I barely gave myself enough room. All right, well, so what do we want to do first? You got it. We got to get rid of those parentheses first, and we could probably combine those two pieces together just to make it a little easier. So 0.01 plus 0.10 better be 0.11x. 0.25 times 44 is 11, plus 0.25 times a negative 2x. Well, that's not going to be positive. That should be minus 0.50x equals our 4.37. All right, so again, we distributed here. So now we still got some x's to combine. So we got a positive 11.11 and a negative 0.50. So what should that give you? Positive 11, negative 0.50. Better be negative. So we got negative 0.39x plus 11 equals 4.37. So now we can start getting rid of all this stuff. So we got to lose the 11 first. Now be careful with the subtraction. So it is going to be a negative because negative 11 is bigger. But negative what? Negative 6.63 hopefully. And you can double check it. 7 and 3 is 10, carry a 1. So that's 4 and 6 is 10, carry a 1. So that's 1 and 4 is 5. 5 and 6 is 11. So it does check. All right. So now we're just going to divide. And again, the negatives are going to cancel, so we do end up with a positive amount. Now, I'm not 100% sure on that, so I'm going to just make sure I get it right. Let's divide that out. So 6.63 divided by 0.39, I think it's 17, yeah. So 17. All right, but don't forget, we got to write our final answer. So we got 17, and that was our pennies and our dimes. So 17 pennies, 17 dimes, and then so how many quarters? Remember, we have a total of 44. We've already used up 34, so that means there's 10 quarters left. Now, if you are not confident, how can you check it? Well, let's see what we get. 17 pennies better be 17 cents. 17 dimes, well, that better be $1.70. What about 10 quarters? 10 quarters better be $2.50. So 7, 3, carry a 1, and there's our 437. So it checks. All right. Loving this stuff, aren't you? Okay, let's try one more, and then we're going to see one final application in the next video. So for opening night of a school production of The Mousetrap, 410 tickets were sold. Students paid $3 each, while non-students paid $7 each. If a total of $1,650 was collected, how many students and how many non-students attended? Well, now we don't have percentages in this case, but we do have rates. How much was the cost per ticket for those different groups? So we have a $3. So again, percent's not really the right title here, but it's probably better if we wrote rate. So $3 and $7. Okay. Now, we have a total of 410 tickets were sold, but we got to split it into two quantities. So how should we split it? Very similar to what we've seen already. If one of them is X, what's the other one? We have to subtract it from the total. So 410 minus X. And so now we can get our products. So 3x and 7 times 410 minus x. But what's it equal to, though? Yeah, remember, we're trying to figure out how to split up this $1,650. So that's what it's equal to on the other side. So now we can get our equation. Whoops. All right. Same as before. I mean, hopefully you're starting to see a little bit of a pattern with these problems. They're all very similar, but you're just going to be careful about some of the amounts. Those are where it's going to get you tripped up. So just be careful with those. So let's distribute. So 7 times 410 is 2870. And then the 7 times the negative x is negative 7x. Okay, so now we got our x's that we can combine. So 3 minus 7 gives you a negative 4x. And now we can get rid of the 2870. So we got to subtract that. So we got a negative 4x equals a negative 1220. So negative 1220. And so our final step, and you can see those negatives are canceling. So 4 goes into 12 3 times and into 25 times. So 305. All right. And then your final solution. So the students was the x. So that's 305 tickets. And the non-students would be what? How do we figure that out? Remember, 410 minus x. So if we subtract 305 from that, that gives you 105. So there's our answer. All right. Hopefully you're feeling a little bit more comfortable about this stuff. I know it's not the greatest area, the greatest type of problem that people like to do, but you can do it. Try to get bits and pieces in there and definitely ask me questions. So one more set of problems and then that wraps up this section. So see you in the next video.